Let's do a problem now with length. So what our equation for length is that the length is equal to the proper length, which is measured in the rest frame, times the square root of 1 minus v squared over c squared. So in this case, I've got v is equal to 0.600 times c. And the observer on the planet measures its length to be 74 meters. So the question is that the proper length or not the proper length? Well, the proper length is measured in the frame at which the spaceship is at rest. So the person on the planet measures the spaceship flying past it. So that's going to be not the proper length. That's going to be L. So then after this, the spacecraft lands and the same observer measures the length again. And we want to know what length does he measure. All right, so I know my V, I know my L. I want to find L0. So L0 is going to be equal to L over the square root of 1 minus v squared over c squared. And now it's just plug and chug. So L is 74, square root of 1 minus 0.600c, all squared over c squared. And again, those c's are going to cancel right out. So I'm going to get 74 over square root of 1 minus 0.6 squared. So that's 74, 1 minus 0.6 squared square root. I get 0.8. So I get 92.5 meters. So the length of the spaceship is actually 92.5 meters. But when it's moving, you measure a shorter length along the direction of motion. And when it's traveling at 0.6 times the speed of light, you actually measure only 74 meters long. Okay, let's do a momentum problem. All right, so what's the equation for the relativistic momentum? The relativistic momentum is equal to the normal momentum, which is the rest mass times v that we did in Physics 1. Again, just divided by this factor, square root of 1 minus v squared over c squared. So what we're told is that we have the relativistic momentum is twice the classical momentum. So the classical momentum is equal to m0 times v. So we're told the relativistic momentum is just twice the relative momentum is twice the classical momentum. All right, so I've got m0v on both sides. So what I know is 1 over the square root of 1 minus v squared over c squared is equal to 2. All right, so now I have to do basically the same kind of algebra that I did for question 2 to get the v out. So first I'm going to multiply the v out. So I get 1 is equal to 2 times the square root of 1 minus v squared over c squared. Divide the 2 on both sides. So I get 1/2 is equal to the square root of 1 minus v squared over c squared. What's the next step? I want to get rid of that square root, so I'm going to square both sides. So square 1/2, I get 1/4. Square the square root, I get rid of the square root. Okay, so now I'm going to add that v squared over c squared over to that side. I'm going to subtract the 1/4 over, so I get v squared over c squared is equal to 1 minus 1/4. And 1 minus 1/4, that's just 3/4, right? So that means that v squared over c squared is equal to 3/4. So now I'm almost there, right? So to get the v by itself, I'm going to times both sides by c squared. So v squared is equal to 3/4 c squared. And so v is equal to the square root of 3/4 c squared, which is, take the square root of 3/4, I get 0.866. And take the square root of c squared, I get c. So it's going at 0.866 times the speed of light. If the problem asks you to actually give the problem in meters per second, you could get it in meters per second by taking 0.866 times the speed of light, 3 times 10 to the 8, to get a number in meters per second. Okay, so again, it's just going to depend on how the problem asks for it, what you do at the end for the last step.